Good morning. My name is Dr. Melanizer, and I'm going to teach you about motion and the world around us. This is a basic concept in physics and IPC, and I'd like to introduce you to it. Our learning goals are just to get you familiar with the basic vocabulary of motion. We're doing this so we can speak the same language in physics and have the same idea going on in our head. You will be successful today if you can understand what position, displacement, distance, speed, constant speed, time, average speed, instantaneous speed, acceleration, velocity, and motion mean in terms of science. Where you are right now is your position in the world. You're seated in front of a computer. The computer is in a different position in the world. Now, you woke up today. That was a different position you started at. And all these different positions have different places in space around us. And in order to really appreciate what position is, we have to have coordinates. We live in a three-dimensional environment. Left and right are our x-axis. Up and down are our y-axis, and probably new to you, z is going towards and away from you. X, Y, and Z axis. These are all your frame of reference to the universe. And whenever we talk about X, Y, and Z and position, we need you to use that framework to understand the universe. Motion, change in position. You are probably not in the same place you were when you woke up. Some of you may be looking at this in your bed, but not most of you. You're probably sitting in a different place and you've moved. Motion is the mathematic term we use to describe how position changes over time. It has the path you took, which is distance, the difference between starting and ending points, displacement, how long it takes you to get there, fourth dimension, time, and how fast you did it, speed, velocity, and acceleration. Time. Time is a really hard concept to explain, but it's this constant progression along the fourth dimension. We can't see it. We really can't experience it outside of its progression and knowing when one thing started and the other stopped. To give you an example of this, you really can't tell how long you slept until you look at a clock. But it's this constant progression. Time is a constant progression in seconds, minutes, and hours. Distance versus displacement. Big concept. Distance is the amount of meters you travel to move positions, where displacement is the difference between starting and ending positions. To give you an example, I woke up today, I drove here to work. I left my bed, went to my shower, went to my kitchen for breakfast, got to my car, drove here. I'm going to work all day. I'll probably wander around campus a few times, especially during my lunch break. And then I'm going to get back in my car. I'm going to go home. I'm going to change clothes, go out again, hang out with friends, possibly in a different city, drive home, and go to bed. That's a day. Now, in that day, I've probably driven and walked hundreds of miles because I like going to different cities where my friends are at. That said, if I start and end in the same place, my bed, my displacement is zero because you started and ended at the same place. However, the distance, I went all around for 100 miles and then came back to the same displacement. In displacement, only the distance between starting and end points matter. Distance is the actual amount of travel you had to do to get there. Speed. Speed is your change in distance over time. In America, we use miles per hour as our primary means of speed, but that's a bit large. It works for cars, and it's a really handy tool because, hey, if you're driving on the highway at 70 miles an hour, I know that I'll be at a town 70 miles away in 1 hour. A place 140 miles away in 2 hours, and 210 miles in 3. That's why we use it. However, we're usually working on a much smaller scale. In the classroom, miles per hour is kind of useless. So in science, we primarily use meters per second. A meter is a little over 3 feet. And seconds, 1 second, 2 seconds, 3 seconds. It's the constant small progression of time. That's what we use to express motion. Velocity, slight change. Speed just tells us how fast we're going. And if you're looking in the car, if you look at the speedometer, that's telling you speed, how fast you're going. But it doesn't tell you how fast you're going and in what direction. If I'm on I-35 and I'm driving 75, that's only telling me it's not rush hour. But if I'm driving 75 miles an hour, I could be going north towards Austin or south towards Corpus Christi or Nuevo Laredo. You don't know. However, velocity will give us a direction as well as a speed. So it's the difference between driving 70 miles an hour or 140 meters a second, 80 meters per second to the north, 80 meters per second to the south, 80 meters per second to the east, 80 meters per second to the west. Velocity is just a speed with a direction attached. Now, acceleration is a change in speed or velocity. Anytime you speed up or slow down, that's an acceleration, sometimes referred to as a negative or positive acceleration, but it's still a change in acceleration. Now, sometimes we're going to change directions. And to describe that, that's actually going to be two accelerations. That's a decrease in whichever speed you are going along one axis and an increase of speed in the other axis. Acceleration is change in speed or velocity. And we express it in meters per second squared or meters per second. Basically, how much do we change speed, meters per second? A continuous speed is moving at a constant speed, no changes, accelerating or decelerating, or changing directions. It's a constant rate of motion. It rarely happens in real life where it's perfect, but constant speed is the easiest for us to calculate. In real life, things are complicated. If I try driving on the highway, I'm gonna speed up and then get stuck behind someone and slow down. And then I pull around them and I speed up and then I slow down. I never was able to maintain one individual speed. And if someone with a radar gun was to keep looking at me, I would be hitting different speeds at every individual point. That's instantaneous. What speed am I doing at a snapshot of time? Now, we're not going to work too much with instantaneous speed, as you really need more calculus to play with that, but we're going to talk about average speed. Average speed is the average of the different speeds you are moving at. Now, you can get this in two ways. One, you can get this by taking all the different speeds you are moving at and add them together and divide them by the number of times, and you'll get average speed. However, more likely, we're just going to take, hey, you started at this point and ended at this point. That was your change in position, and there's your displacement. And then you divide it by the amount of time it took. That is average speed. It can be kind of inaccurate because what distance you traveled, but it teaches you what the average amount of time to get from point A to point B is. And those are our basic terms in physics for motion. If you have any questions, here are our emails. Thank you, and have a good rest of your day.